So we're now going to talk about how Java completable futures help to overcome the limitations with Java futures. We talked briefly about completable futures when I introduced the concept of reactive programming, and we talked about the reactive model with responsiveness, resilience, elasticity, and message passing, message-driven behaviors. Now we're going to go into more detail, but this is still just kind of making that transition. So we're going to talk about how completable futures overcome the limitations with Java futures and help to fight complexity. Once again, I had fun with generative AI and DALL-E generating something that showed fighting the dragons of complexity with completable futures. That's what it came up with, which I thought was actually pretty good. So let's talk about this. So how are completable futures going to overcome the limitations with futures? Well, we're going to see that if you program with Java futures, you have a very complicated maze and twisted path of complexity. If you program solely with Java threads, you have a maze of complexity. If you program with Java completable futures, you have a nice path that leads you into the guiding light of harmony and perfection and clarity. So let's see how we can do this. The first thing you can do with completable futures, which is a minor issue, but it does make somewhat of a difference in practice, and we'll see some examples here shortly, you can complete them explicitly. So you can create an incomplete completable future, which doesn't have any computation associated with it. You can then spawn a thread or do some other way to get a computation to start running asynchronously. And then at the appropriate point in time in that thread's life cycle, you can complete the future and give it its result. And when you do that, any other thread that's waiting for the result to complete can be joined with, and then you'll get the result. So you can explicitly complete completable futures. We'll see an example of this here shortly. Not the most useful, not the most important feature of completable futures, but an interesting feature nonetheless. And you actually get to play with this in programming assignment number 4. Something that is actually quite useful is to chain together a group of dependent actions using something called CompletionStage methods. And what happens here, just as an example, we can start an asynchronous computation to reduce a big fraction. We can then, after that finishes, convert that improper fraction to a mixed string or a mixed fraction, and then we can accept the results of that and print it out. So this code actually runs asynchronously, but it looks synchronous in the way that it's programmed. So it makes things cleaner and very efficient. So therefore, asynchronous programming looks like synchronous programming, but it's actually running asynchronously. That's kind of a cool feature. And that gets around that callback hell problem we talked about that was a limitation with simpler models of asynchronous programming with futures. Something else you can do with completable futures that you can't really do with traditional futures is you can have them triggered reactively and efficiently as a collection without undue overhead and undue complexity of programming. And we'll take a look at an example that does this. You'll get lots of chances to play with this when you do assignment 4, where we're going to start some computations running in the background, and then we're going to collect all the asynchronous computations as they complete into a single completable future that will complete reactively when everything else is done. So this particular mechanism, which you'll get a chance to play with in assignment 4, makes a single completable future that will be triggered when all the other completable futures complete. And then when that happens, we can print the results. So it's kind of cool. Notice I use the word future here, but I'm referring now to completable future. Completable future is a bit of a mouthful, and it takes up a lot of space on the slide. So I say future, but it's really completable future. You can also combine completable futures and their asynchronous properties with Java sequential streams. So you can get kind of the best of both worlds. It's my metaphor of perfection and balance and harmony, like a peanut butter cup that combines chocolate and peanut butter, which I like. If you don't like it, that's the wrong metaphor for you. But for me, that's like the pinnacle of desserts, especially when Halloween comes around. I always hope that the kids don't take the peanut butter cups because then I can eat them afterwards. But basically, what you can do here is you can combine completable futures for asynchronous processing with sequential streams for a more coherent control flow through your program. And you will also get a chance to play around with that in programming assignment number 4. So that's a quick overview of the features that were added to Java Completable Futures to make them overcome some of the downsides or the drawbacks with classic Java futures. At this point, you still would be hard-pressed probably to write complicated programs using Completable Futures, but that's what we'll talk about in the rest of the slides.